Okay, more ideal gas law problems. So again, we're performing calculations involving temperature, temperature T, if my pen will work, temperature T, pressure P, volume V, number of moles for gases, and of course for these we always know that R equals 0.0821 liters, atmospheres per Kelvin moles, and those tells us the units that we should definitely get everything else into. Okay, so the question we have now is a 10-liter balloon contains helium gas at a pressure of 655 millimeters of mercury. So this we know is a volume, this we know is a pressure. What is the new pressure at 20 liters, another volume? If there is no change in temperature, that means T is constant. Okay, so we know that we're going to have to make a derivation of PV equals nRT because T is constant and we are looking at pressure and volume. So the way to do this, there's a couple different ways. Number one, you can just memorize that P1 V1 equals P2 V2. The other way to do it, which is actually extremely easy for pressure and volume, is to look at where they are in the equation. You can set all of the variables on one side and all the constants on the other side. So at initial quantity 1, initial equals nRT. These are constant, they don't change, they don't get numbers. And we know that at the second condition, it'd be P2 V2 equals nRT. And we know that these two are the same. And if A equals B and B equals C, that means A equals C. So that would mean P1 V1 equals P2 V2. That's the derivation, or you can just look at this. They're on the same side, so you're just going to write it twice. P1 V1 equals P2 V2. Okay, so that's the correct one. This is not the same as the volume. Volumes on opposite sides. On opposite sides, we would divide. So it'd be V1 over T1 equals V2 over T2. And so it's really important to make this distinction. Okay, lots of people mess up this kind of math. Okay, so now we've got this wonderful formula. P1 V1 equals P2 V2. We know that's the one we're going to use because T is constant. We're going to go ahead and plug this in. Okay, using the correct units. So now we have to figure out what's P1 and V1 and what's P2 and V2. So a 10-liter balloon contains helium gas at a pressure of this. So we know that this pressure, we'll call it P1 and V1, they go together because it says this volume at that pressure. What is the new pressure? So that's going to be P2, and we don't know it, at 20.0 liters, and that's V2. So we're going to be solving for P2, and I'm going to go ahead and solve for that first. P2, but by dividing both sides by V2, those cancel. There we go. So P2 equals P1 V1 over V2. Okay, so next up, we got to convert this 655 millimeters of mercury to atmospheres, just to make sure that we're always on the right track here. So 655 millimeters of mercury. And from our conversion table, we know that 760 millimeters of mercury are in 1 atmosphere. So this will give it to us in atmospheres. And just looking at this number, we know that it's going to be a little bit below 1. So that'll be a good check. And doing the calculation, yeah, it's about 0.862. Same number of sig figs, 862 atmospheres. Okay, so we're going to go ahead and plug that in. Equals 0.862 atmospheres. V1, looking back here, it was 10 liters. V2 was 20.0 liters. Okay, so our P2 is going to be 0.862 times 10 divided by 20 is 0.431 atmospheres. Okay. And for you more advanced students, if that made sense to you, keep it exactly like that. If you really understand the units and when to use the units appropriately, you might be asking yourself, why did I go ahead and change this millimeters of mercury to atmospheres? And that's because if you change it to atmospheres every single time, you're going to get these answers right every single time. In this particular case, we could have reported this in millimeters of mercury and it would have been fine. But just to make sure, I always convert everything. I convert my volumes to liters, I convert my pressure to atmospheres, I convert my temperature to Kelvin, and moles you typically don't need to convert. But the temperature really, really, really matters. The volume and the pressure don't matter as much because this involves addition to make Kelvin. These involve conversion factors. So if you're involving a conversion factor, it's really the same number. But when you're adding, it's definitely a different number. So if that made sense to you, that's fine. You can do the problem that way. If it didn't make sense to you, always convert to these units.